Hi friends, welcome back. Today we are going to solve another recent and quite popular Leetcode coding interview question 2662, minimum cost of a path with special roads. So this is another quite popular medium complexity coding interview question on Leetcode. So we are going to go through this problem today. We are going to understand this problem with some examples, and we are also going to implement our Java solution to solve this coding problem. If you are new to this channel, please subscribe to this channel now. Also click on the bell notification icon button right away so you won't miss any important postings from this channel. Here we create content and videos to help others in their interview preparation and learning different computer science concepts along with data structures, algorithms, problem solving, logic building, programming and coding. So let's start. You are given an array start where start is equal to startX startY represents your initial position startX and startY in a 2D space. You are also given array target where target is equal to targetX comma targetY represents your target position targetX and targetY. Okay. The cost of going from position x1 y1 to any other position in the space x2 y2 is distance between x2 and x1. So x2 minus x1 absolute difference, y2 minus y1 absolute difference. You have to add them together. That is the cost, right? There are also some special roads. You are given 2D array special roads where special roads I is equal to x1i, y1i, x2i, y2i cost of I. It indicates that the ith special road can take you from x1i, y1i to x2i, y2i with cost equal to cost I. You can use each special road any number of times. Return the minimum cost required to go from startX startY to targetX targetY. Okay, so we want to find out minimum cost to go from starting position to target position, right? Minimum cost. Okay, so there are two examples here. So constant says that the start dot length is equal to target dot length is equal to 2. One is less than equal to start x less than equal to target x less than equal to 10 raised to 5. One is less than equal to start y less than equal to target y less than equal to 10 raised to 5. Special roads dot length is between 1 to 200 inclusive. Special roads I dot length is equal to 5. Start x less than equal to x 1i x 2i less than equal to target x. So these are the constants that are given to us. So let's take a first example so it will be more clear what they are saying, right? So this is the first example. So I just created one graphical representation also for you here. So this is the starting position where you are, right? And this is where you want to go. This is the target position, right? So this is a kind of a 2D space, right? So let's say 1 2 3 4 5. So it's just kind of a matrix here. So this is 1 2 3 4 5 here, right? So the starting position is 1 1 here, correct? 1 1 is the starting position. Target position is 4 5 here, right? This is the target position you can see here. Special roads are also denoted here. So this is a special road, right? This is another special road, right? So the cost is also denoted. This cost is 2 here, the cost is 1 here, correct? Now what they are saying is if you directly want to go from starting to ending position, then you have to how you will calculate the cost. For example, your point is, let's say 1 1 is your point and your target point is for example 4 5, right? Then you have to calculate the cost according to their this distance rule, right? So absolute difference between x2 and x1 and absolute difference between y2 and y1 you have to add. So absolute difference between 1 and 4 is 3. Absolute difference between 1 and 5 is 4. So you will have to add them together. So it will give you distance 7, right? So if you just directly go without taking any shortest path or anything, then that is what you will encounter. That is the distance, right? Now we want to find out minimum distance. Here we are also allowed to take the special roads. So what is the special road? The special road can take you from one point to other point in some cost, right? So sometimes that cost may be smaller, right? So it can be beneficial for us to take special road. For example, if you go from this point, which is 1 comma 2, right? 1 2 is your position, and if you want to go here, which is 3 3, right? 3 3 is your position. If you just take your normal road, then how much it will take you? So distance between x2 and x1, so 1 minus 3, which is 2, right? Absolute value plus absolute value of 2 minus 3, which is 1, right? So plus 1, so it will take you 3, cost 3, right? Normal distance, no special road. Now if you take the special road, it is giving you cost 2, so it is saving your cost, correct? It is saving your cost because normal cost is 3. If you don't take any special road, if you take special road, cost is 2, then we should choose the special road, right? Because it is saving our cost. Okay, so now let's take this example where we can take this one road. This is one distance, then this is 1 plus 2 is 3, right? 1 plus 2 is 3, 3 plus 1 is 4, and 4 plus 1 is 5. So in 5 distance you can reach from source to target, right? This is the minimum distance in this case, right? So this is what we want to find out. But now you have to remember that we have taken a special roads here, right? That's why the distance is minimum. If you don't take any special roads, it will take 7, right? So we have taken special roads, so it is taking us 5 cost, right? So this is what the problem is basically. So now you understood the problem, I hope, with this explanation and with this example clearly, right? So how can we solve this problem? So this kind of problem we can solve by using BFS, right? We can use a BFS approach here. So BFS stands for breadth first search or breadth first traversal. BFS uses queue. Here also we will use queue, right? So starting point is known to us, right? So we will add this starting point into our queue, and uh, we will start expanding BFS, right? So you will start going into the position, next positions. Let's say you also will keep track of the special roads that are available, right? So for example, this special road, is it saving you any distance? Yes, it is is it saving you any cost? Yes, because actual cost is 3, your cost by taking special road is 2, so you will add that into your special roads. It means that we want to consider this special road basically, right? Because it is saving us cost. You got it, right? We want to consider this special road because it is saving us cost, right? This special road, do we want to consider? Yes, because this will also save us a cost, right? For example, if you don't take the special road here, then you are at 3 4, your original location, you want to go to 4 5, then how much it will take you? 1 plus 1, so it will take you 2 cost. If you take special road, your cost is 1, so it is giving you benefit, right? It is saving your cost, so you want to consider this special road. So we'll keep track of that, like what special roads we want to consider. If it is saving our cost, then we will consider those roads, right? So we'll start expanding from starting position, and we'll start expanding, and we'll try going to the target position, right? Whenever you reach a point, for example, you reach here, right? You will check if there is any special road which starts from this point, right? So yes, there is a special road which starts from this point. Then we will add this special road, right? Because this is beneficial, this will save us a cost, so we'll add this special road into our queue. So you will directly reach here, right? You will reach to this point if you take special road, right? Again you will try expanding from here. Let's say you go to here, right? Now here to here there is no special road, normal road, right? Normal road cost will be 1. Okay, after that, here to here again you will check if there is any special road. Yes, there is a special road, so you will consider this special road, right? Because it is saving your cost, that's why you will consider the special road, right? Whenever you reach the target position, then that time you will actually find the minimum cost, because we have used BFS, right? We have used BFS, and we also have used the logic where we will use special roads to our advantage so that we can save the cost, right? So this is the approach to solve this problem using BFS and queue. So let's directly go to the code now, so you will understand how to write the code for this approach. So we'll create one coordinate class, right? So it will hold the coordinate xy, right? Two things we want, right? X and y coordinate, and we also want the cost to reach to that coordinate, correct? Cost to reach there from the starting point. Okay. Now here is our main function, like main method minimum cost. So you get start array, you get target array, you get special roads array, right? Three things you will get. You have to return the minimum cost, which is integer, right? Now here you will create one list of integer, which is an array list of integer. In this for loop, you will start looping through all the special roads, and you will try to check if it is worth to take that special road. How will you decide is it worth to take the special road? Because you will calculate the normal cost to go from that point A to point B here, right? You will calculate normal cost from point A to point B without special road, and if that cost is greater than or equal to your special road cost, then you will add that into the list. It means that it's worthwhile to take the special road because it's going to save some cost for us, right? So we will consider that at that time, right? So this is the so we already know which special roads are worth to take. Okay, at this point your list will hold the indexes of the special roads which are good special roads. Good, why good special roads? Because they will save us the cost, right? So we will add that indexes into the list, right? So what did we do here? We just calculated the normal distance by using their formula, right? So absolute difference between x1 y1 and absolute difference between x2 y2 and their uh, addition, right? So absolute difference between x2 x1 and y2 y1, and we are adding them together, right? Okay, now here so now we understood that already what are the beneficial roads. We have it in our list. Now we'll create one variable mean cost. So first initialization, we'll just say that we will not take any special road, we'll just go by using normal road. If you go by using normal road, then the cost you will calculate here, right? Just same thing, x1 minus x2 plus y1 minus y2, add them together, it will give you normal road cost, right? And n is equal to 1. After that you will create a queue. Queue is going to hold coordinate objects, right? And this is a priority queue. Okay, this is a priority queue, this is important. We are going to add two coordinates. How we will compare it? We will compare it based on the cost. So the minimum cost coordinate will come first. Okay, minimum cost coordinate will come first, because this is how we have created the priority queue, right? After that we'll start adding the coordinates. So first starting point for us is the actual starting point that is given to us. For example, in this case, this is your starting point, which is 1 1, right? 1 1 is the starting point you will add into the queue, correct? And then you will create a set of string, we will call it as a visited, because those points are already visited. So it means that you already found the shortest path to reach to that point, right? After that you will start now iterating through the while loop. This is the BFS starting point. So while q is not empty and mean cost is greater than the q dot peak dot c, so it means that your minimum cost is more than your current cost that you are seeing, right? So it means that there is a room for improvement. If there is a room for improvement, then we are going to improve the cost basically in this while loop. So this is the BFS. Okay, so you will remove the coordinate from the queue, right? Q dot pol will give you the current coordinate, right, which will be the minimum distance from your starting point to that point basically, right? And you will check if you reach the target position. So c dot x is equal to target 0, which is x coordinate, and c dot y is equal to target 1, which is the target y coordinate. If that is the case, then c dot c will give you the minimum cost to reach to that point, because we are using a priority queue and we are using a BFS. Okay, let's say you did not yet reach the um, target point, right? So you have to now still go further basically. So you will get the c.x plus c.y. You will append this with by adding a space here, and you will create one point string, right? And you will check if this point string is already visited. It means that that point is already visited or not. You want to check, right? Because if you already have visited that point, there is no point to again visit it, right? So you want to check it if it's already visited. If it's already visited, you will simply continue in the loop, right? Let's say it's not visited, then you are going to add that point string into the visited. Because we have now visited that point, we will start iterating through all the special roads here in this for loop. This is important, right? Iterating through special roads, right? So these are special roads which are giving us benefit, right? Benefit because they are going to save us the cost. Only those roads we will use, okay? After that, here you will check if the special road, your ith special road is actually starting from this current point, right? C.x is equal to special roads of I0 and C.y is equal to special roads of I1. It means that it's starting from this point like this. So let's say you are here, so it is already starting at this point. So you want to calculate how much cost it will take to reach to this point. So this cost is 1 plus 1 plus 2 is this cost will be 3 here, right? Total cost. So that's what you will calculate here. So cost will be special roads I4 plus C dot C. So you will calculate the cost just I shown you. So 1 plus 2 you will calculate 3. So to reach to this point your cost becomes 1 plus 2 which is 3. Okay. So that's what you calculate. So special I4, why is I4? Because fourth point is the cost here, right? So if you take a look, this is the special road description. So this last point, which is the fourth index, is the cost, right? This is the cost, this is the cost, right? So that's what we are actually reading here and adding it to our current cost, correct? After that, you will check if this special road ending point is already not visited, right? The ending point you are checking. Now what is ending point? So let me show you. So what I mean to say is this is the starting point of special road, this is the ending point of special road, right? So you want to check if this is already visited or not, right? This point is already visited or not, you are checking here. If it's not already visited, then it means that we want to go there and visit that point, right? So you will create one coordinate for that. So new coordinate special roads I2 comma special roads I3 cost, right? So you know the new cost because you already found the cost, for example 3 in this case. So to reach to this point using special road it takes 3 cost, correct? So that's what you will put here in the new coordinate, and new coordinate you will add into the queue so that it can be processed further through BFS. Okay, so at this point you are clear until this point. Now else it means that this is not the starting point. Okay. So you will come here now, else means it's not a starting point of the special road. If it's not a starting point of the special road, then you want to consider if you like considering ith special road from current point and calculating the cost, right? So you want to calculate the cost to the ith special road, c dot x minus special roads I0, c dot y minus special roads I1. So you will do math dot absolute so that you calculate that cost and you will add your current cost, right? So you will get the cost to reach to the special road starting point from the current point. Okay, I'll repeat this sentence for you. You are finding the cost from current point to reach to the ith special road starting point here. Okay, once you reach there, once you find the cost, you will check if this the special road starting point, right? Special road starting point, is it already visited or not, right? Special roads I0 plus special roads I1. So you will check in your visited set. If it is already not visited, then you are going to visit it. So you will create a new coordinate here. So we are creating a new coordinate here. Special roads I0, special roads I1 cost, and you will add it into the queue, right? So this way you will keep looping through this while loop. So this for loop is to iterate through all the special roads that are giving us benefit. What benefit? We are saving the cost. So you will check all the special roads for that coordinate, right? And this is your while loop, which is outer while loop, right? So you will keep iterating. Here you will also keep adding the cost of your target point from your current point, right? So you can see here that new coordinate target 0 comma target 1, absolute of c dot x minus target 0 plus c dot y minus target 1 plus c dot c. So you are also adding another coordinate here, saying that you are just directly going from the current point to the target point, then how much it will take without using any special roads, right? Without using any special roads. So that also you are adding into the queue. The queue will always pick up the smallest cost because that's how we have created the priority queue. If you take a look here, it always gets the smallest cost, right? E1.c minus E2.c. So this is how the priority queue is created. So this is a very important point to note, okay? That's why you always, when you reach to the destination or your target point, you must have found the smallest cost basically, right? So that mean cost you will have to return, right? So mean cost is what you will return here. Okay, the mean cost will come from here, right? So mean cost you will find here. So if you reach the target, you will get the c dot c will give you the cost, which is minimum cost. If you never reach the target, then your minimum cost will be this original cost, right? Which without any special roads, right? So let's execute this code, make sure it works with test cases. So for the first example, we are expecting 5. Let's take a look. We are getting 5, which is a correct answer. For the second one, we are expecting 7. We are getting 7 correct answers. Submit this code now to the Leetcode. Make sure this code gets accepted. And as you can see, the code is successfully accepted by the Leetcode. It is 54.57% faster on the performance side and 26.53% faster on the memory usage, which is a very good solution to solve this coding problem. 2662 minimum cost of a path with special roads. Another quite interesting and important medium complexity popular coding interview question on Leetcode. Very recent question. So I wanted to show you this logic, how we can solve these kind of problems today. So important things to note about this solution is we have used BFS, we have used priority queue to solve this coding problem. So I hope you like this approach and you like this Java solution and you understood it completely. So I explain you step by step completely. So I'm going to add this code for you in my GitHub repository and give you the link of my GitHub repository so you can check out the other solutions there. There are lots of other important programming and algorithmic solutions available there in the GitHub repository for you. Those are important ones. Those are recently asked questions by big tech companies in their interview rounds. A lot of PL SQL, MySQL, Oracle, Java J2E and Unix solutions are available there in the GitHub repository. If you like those solutions, then consider giving it a star on the GitHub repository. That would be great. If you are new to this channel, there is a very important coding interview related playlist we have created to help your interview rounds. It is called as Leetcode and Leetcode Solutions. More than 200 most frequently asked very important coding interview problems are compiled for you under one playlist. Those problems are asked by many big companies including Google, Facebook, Amazon, Apple, Microsoft, Yahoo, Uber, Lyft, LinkedIn, Netflix and many others many times in their past interviews. They are very important coding interview problems. Make sure you go through all of them, understand them thoroughly. If you go through all those videos and problems, you are going to learn a lot about data structures, algorithms, problem solving, logic building, programming and coding. It will also help you learn lots of new techniques, new ways of problem solvings. So do check out the solve coding problems. The name of the playlist is Leetcode and Leetcode Solutions. Now if you are a fresher, junior level developer and you want to practice more coding problems for your interviews, to help you with your practicing, we have created 3 other playlists for you here on this channel. The names of those playlists are Codeforces, CodeChef, AtCoder. If you go to the playlist of this channel, you will find those playlists listed out there. Lots of interesting, important and exciting problems are waiting for you there. If you like this today's Java solution where we have used BFS and priority queue approach to solve this important coding problem on Leetcode 2662 minimum cost of a path with special roads, then please give it a thumbs up to this video, give it a like to this video, subscribe to this channel. Subscriptions are very important because that's how the videos can reach to other people, so others will also be able to watch and learn from this channel. So do subscribe it, share this content with all your friends and colleagues so they will also learn from this channel. If you want to practice for Java J2E rounds of interviews, there are lots of Java J2E related videos we have created on this channel to help others. For example, frequently asked Java telephonic interview questions and how to answer them, Java design patterns, Java architecture, SQL programming questions to the freshers, where they will give you database tables, they will ask you to write SQL queries, where you may have to use different database related concepts like inner join, outer join, left outer join, right outer join, aggregate operations, group bind, having clauses, different where clause conditions, important windowing and ranking functions along with partitioning. Everything is demoed and explained on this channel with example SQL queries and SQL tables for your easier and clear understandings. There are videos that discusses Unix questions are also available here. For example, Unix commands, Unix utilities, shell scripting questions all are here on this channel for you to help you in your interview preparation and learning different computer science related concepts. If you want to learn more data structures, algorithms, and you want to learn more programming and coding, then there are lots of solve coding problems videos on this channel available for you. For example, dynamic programming, graphs, matrices, binary search trees, breadth first search, depth first search, cadence algorithm, binary search algorithm, Kruskal's algorithm, Dijkstra algorithm, sliding window algorithm. There are lots of other important data structures related coding interview problems are also available for you here on this channel, including stacks, queues, priority queues, hash table, hash map, tree set, hash set, linked hash map, linked hash set, arrays, linked list, all are important problems. Those are selective coding questions. Those are asked by big tech companies many times in their interview rounds. So make sure you go through them, understand them completely. They will give you good preparation for your interview rounds, will help you learn more concepts of computer science and programming. If these videos on this channel are useful and helpful for you, you are learning more programming, coding, problem solvings by watching these videos, then please do leave your messages, feedback and comments below these videos. Your feedback, your messages and your comments are very important for us. They increase our motivation to create more quality content videos on this channel to help others. So others can also learn problem solving. Others can also learn programming. They also get helped in their interview preparation process. If you want us to create videos about any specific topics, then mention those topics as well in the below comment section box so that we can create those videos for you here. Soon we are going to be bringing lots of interesting and important database fundamentals of PL/SQL programming and Unix related videos for you on this channel, where you can learn how to write SQL, stored procedures, functions, triggers, what is the importance of them, how to solve PL/SQL programming questions, what are the important functions as well as important concepts to use while solving those problems. So everything will be explained in those videos with real-time examples for your easier understanding. So stay tuned, keep checking out the newly added videos here. Lots of interesting videos for you are going to be coming soon here. Keep learning, keep coding, keep solving more varieties of coding problems, and most importantly, keep your learning process and practicing going on continuously. And thanks for watching these videos.